This is Unit 2B.5b. This is for Algebra 2 of Trig. We'll be factoring and solving polynomials. We'll be putting them on graphs. So we're going to factor the polynomial, and we're going to use those factored form to graph the polynomial. So in a previous lesson, we learned about a cubic with 4 different terms. Sometimes you can factor by grouping. So to factor by grouping, we're going to group the two groups together, and we get x squared, x plus 2, bring down your negative. Nothing factors out of x and negative 2, so we have to put down something, so we'll put down a 1. And then you'll notice that negative 1 times x makes negative x. Negative 1 times positive 2 makes negative 2. So that's why this is a positive 2. Both of these have to be exactly the same. Notice that they're the same. So your factors are going to be x plus 2 and also your leading coefficients, x squared minus 1. Now, we need to be sure to factor completely. So x squared minus 1 is actually the difference of two squares. So that can be factored one more time. X times x makes x squared. A positive 1 and a negative 1 makes 0 in between. And then negative 1 times 1 makes negative 1. So those are your factors along with your x plus 2. What we recognize is that this is to the third degree. The more important thing is to realize that this is odd. Yes, it's to the third degree, but odd is what we're really paying attention to. That tells us it goes in opposite directions. That is the graph. The graph will go in opposite directions. Now for end behavior, because we have a positive leading coefficient, we know that it's going to go into the positive direction. And then that means it's because it's odd, it's going to go into the opposite direction. Okay? So, let's figure out just where it crosses. So we are setting each one of these to 0. We are solving for the zeros of the function. So x minus 1 is going to be 0. X plus 1 could be 0. And x plus 2 could be 0. And we get 3 different zeros of the function. We get it at 1, we get it at negative 1, and we get it at negative 2. So to graph this, because it has 3 intercepts, it's going to flow right through each one of those and go straight up. Okay? There is no bouncing because we don't have any repeated zeros. That means we don't have any double zeros. So it goes through each zero of the function. We don't have to worry about how high or low we go up. Okay, what we're trying to do is use the end behavior and the zeros to predict basically what the graph looks like. So we're not using our calculator. We're not going in there to get the table. We don't have to plot any additional points. We just have to know that we'll be going up and down and flowing all the way through each one of those points. The closer the zeros are together, the closer this comes down to 0. And the farther they are apart, the farther away from the x-axis or the 0 value it is. The end behavior, when x approaches negative infinity, the function, as x goes to negative, the function is going down. As x moves to the right, or as x becomes positive, we see eventually the graph is going way up high. Because it is an odd degree, we know these are going to be different. Because it is a leading coefficient that's positive, we know that when x is positive, the function is positive. And then they go in opposite directions. Another way to think about it. Okay, here's another problem. You go ahead, pause it, try to factor this apart, figure out what your zeros are, draw your graph, and then play the video and see how you did. So, welcome back. I would suggest to factor out the negative with the x's, and you have an x squared that can factor out. So that's going to leave you x, a negative, and a negative makes a positive, 4. So remember, it's going to be of 0. And then here we have x squared, that might equal 0, or x minus 4 could equal 0. In this case, we're going to get a double 0 at 0. It's a double 0 because x squared equals 0. That means x times x are both 0. Two different zeros. And here we're getting 4. So that means we have a 0 at 4 and we have a 0 at 0. We can draw it twice if we want, because it's a double 0. But we'll talk about what that looks like on the graph here in a second. The degree. We see the degree is 3, but more importantly is that it is odd. It's an odd degree. The end behavior. Notice that the leading coefficient is a negative. So we have a negative leading coefficient. A negative leading coefficient. If it's negative, we know that the graph is going to be going down to the right. And since it's odd, you know it's going to be going up. It's going to go in the opposite direction, because that's what odd functions do. Now, because the 0 is a negative, the 0 is a double 0, at 0 in this case, it's going to bounce at that location. Okay, we did not use our calculator. We did not plug in additional points into a table. We calculated what the zeros were. We noticed that this was x squared equals 0. So that means that there's two different x's equaling 0. So that's what made it a double 0. So that's how we got our graph. Don't forget to write your equation. So up here, this would be f of x equals x cubed plus 2x squared minus x minus 2. And down here, this would be f of x equals negative x cubed plus 4x squared. Our end behavior, when x moves to the left, when x gets small or very negative, the graph is above it. The graph approaches positive infinity, and as the graph moves to the right, or when x's get bigger, the graph is below it. The function is negative. All right, last one down here. We have a jewelry box. So that means, like in geometry class, when you learned about prisms, there's our beautiful jewelry box. It has a length of 2x. It has a width of x minus 1. And it has a height of x minus 3. If the volume of the box is 24 cubic inches, then what are the dimensions? Well, if I know that my sides in terms of x are these, I know my volume is that. Volume is length times width times height. So 24 is going to equal 2x, x minus 1, x minus 3. So if I go ahead and group those together, so I FOILed here, now I distribute there, so I get 2x cubed minus 8x squared plus 6x. I'm going to move the 24 across. So 0 equals 2x cubed minus 8x squared plus 6x minus 24. I still don't know what x is. For me to figure out x, I have to be able to factor it apart. Now, some of you might think these were the factors, but these multiples gave us 24. I need to figure out what makes 0. So we factor out the 2x, and that leaves me, 2x squared. That leaves me x minus 8. Bring down the plus, factor out the 6. X minus, this would actually be a 4, not an 8, huh? X minus 4, and this would have to be minus 4. Notice the parentheses are exactly the same. I get 2x squared plus 6, because those are my coefficients. And I have my x minus 4, because both of those are the same. These all equal 0. So we could do this one more time. We could bring the 2 out, and that would leave me x squared plus 3. And here it would be x minus 4. So that had a common factor. If you looked up in the beginning, they were all even numbers. We could have factored the 2 out from the beginning. But we waited. We did it when we needed to. So what we're going to do is set everything equal to 0. And 2 can't equal 0. X squared would equal negative 3, and we would take the square root of negative 3, which would give us an imaginary solution. So that's not really an answer. Okay, when you're taking the square root of a negative, we use the letter I, which is imaginary. Then we have x minus 4 equals 0, x equals 4. Well, 2 can't equal 0 because 2 equals 2, so that's not a solution. Here are 2 answers, but they're both imaginary. This is your third answer. This is a cubic equation. There are 3 possible answers. 2 of them are imaginary, 1 of them is real. So 4 is your value of x. So your dimensions are 2 times 4, which makes x, 4 minus 1, which makes 3, and 4 minus 3, which makes 1. This is 8 inches, 3 inches, and 1 inches. All right, good job, everybody.